think we should get started?
Sure.
All right. So I think I have the ability to finish everything within the hour, but time always gets away. So let's get a move on. Mary Schweitzer approached me a couple months ago saying we want to have these brown bags over the summer. Do you have anything you'd like to present? So I'd had this idea for a long time of a script that I use a lot, redeveloping out on the fly, showing how increasingly complex use cases drove further development, and we thought that sounded like a good idea. It's kind of tongue-in-cheek, the title that we came up with, but if you measure the metric on somehow hours of labor saved divided by lines of Perl, I think we could get a really big number. And I'd be interested if anybody could challenge me with a Perl script that they thought might be more useful according to that metric. Okay, so why do we even do Perl at all? Basically because stuff is boring. And if you're ever doing anything with a computer that's boring and repetitive and mindless and the same thing over and over and over, how would you ever do any of that on a computer? That's what computers are for. So usually you can find a way to have Perl do that for you. And then usually what happens is when you automate it, you find that the tool that you made to automate that boring task can be used as is or slightly expanded to cover even larger tasks that you never even would have dreamed of tackling in the first place. But then your horizons are widened. And if you think about it, that's what computers are all about, right? So let's take a look. Before we do that, I just want to quick pop over to an interesting case. Kent Cross sent me this link a couple weeks ago. I don't know if you've seen this. I can send it to you if you're interested afterwards. But it's a great little story about this guy in the Army National Guard, the Arizona National Guard, that was deployed in Iraq, and he used Perl to take care of a problem that was boring him on his job. He says in here, constantly looking for ways to make my job easy. I didn't want to do all this stuff. I was far too lazy, and it was horribly inefficient. Good programming is always driven by laziness. We want to do things in an efficient way. And it turns out he saved time for the Army, which is our tax money, and he got a medal. And I thought that was super fantastic. I'm not going to win a medal for this, but I hope that we can achieve the same objectives. We are too lazy to do something that's boring, and so we come up with a tool to do it for us, and then we finally can do a lot more things. So I'm sure you've run into this problem before. We've got a whole bunch of files that come from some automated process, and so they have file names that are pretty repetitive, very long, unwieldy, and you want or need them to be something smaller and simple. So if you have file names like that, it's not too much of a hassle if you just got 10 of them. Just go through and type the commands. Okay, we can handle that. But what if there's more files? If you have to spend time doing that 47 times, then it's going to be boring for sure. 10 you could probably soldier through. If the number keeps increasing, well, 147, that's just kind of silly. That's really a waste of time. It's not productive, it's inefficient, and it's costly. It's not a good way to do business. And if the number keeps increasing, then it's not just boring and expensive, it's also stupid, because not only are you wasting a lot of time, but you're doing this task manually, and it's going to have errors creep in because you're not going to do it as perfectly as an automated process would. And so that's going to cause problems that have to be fixed eventually. Nobody would ever do that. So let's automate it instead. What if we had a Perl script just to do this job, where we'll call it multi-move, and we can take this string that we don't want to be in our file names, too long file name 00, and just replace that with an F. And it can generate all the commands that we need to type, but it can do it a lot more fast and a lot more accurate. And it doesn't matter if it's 10 or 47 or 10,047. The script can do it for us way faster, 100% accurate. And as we will see, we can get a lot more things done with simple expansions to this concept.
Hey, Ruben.
So, yes.
We don't see any slides online. Are you sharing?
I think there should be, is that Ryan?
Yep.
Hi, Ryan. Do I need to share the desktop or anything?
Yeah, try sharing desktop. I don't see anything shared. At least 3 other people online don't either.
I'm glad we didn't mute you yet. Can you see me doing the AT&T app right now?
I can't see you do anything right now.
Okay, so it's not just that I remoted over. Anybody know how to find this thing called cards to share?
Who's the presenter?
Yeah, if you just share the remote desktop application, that'll be everything.
Yeah, where is this?
App sharing? Yeah, try that.
Okay.
Yeah.
Is that working?
How's that?
It looks like it's coming up now. Yep, now I see it. Thank you.
Great. So we're going to get started writing this script multi-move, and then we'll expand beyond that. So here's the plan. First of all, I'll just briefly show you that I have a script to make scripts, because it makes scripts easier. There's a lot of boilerplate in almost every script that I write that is easy to automate. And then we're going to implement this multi-move script. The basic outline is we're going to give a before pattern and an after pattern. The job will be then to find all of the files in the current directory that contain the before pattern. We use a regular expression to create a new target file name where we've substituted out the before pattern with the after pattern. So we have a before file name and an after file name, and we build up a command that does move before, after. We print the command to the screen to inspection so that we can inspect it before we do it. We'll also implement a test switch so that we can see whether it's going to look right before we actually change anything. And then finally, we'll send the command to the operating system for execution. All right, so here I am in this cans directory. All of these are zero-length files. There's not actually in them. I just created empty files with names to it so I could change them. You can bet I used my script to do it. So let's first of all, on a new script called multi-move. And here it is. I hope that font is big and colorful enough for everybody to see. But the boilerplate that goes into almost every one of my scripts, this is find bin, so it has this variable in it, which is the directory that the currently running Perl script lives in. And that's useful for setting up, you can say, use lib of that directory, which means that if you invoke a Perl module of your own that sits in the same directory, it'll find it. You don't have to wrangle the include path. This is the simple way to manage command line switches. I can never remember the syntax. I always have to look it up, or it's in here from the automatically created script. It's set up to have one implemented command line switch, which is H for help, and this is my way of self-documenting. So there's a usage statement that says, oh, that's the name of the script that I just said I wanted to make, and it has an H switch, and it will print this message. This is the thing that actually goes out and checks the command line and fills the opt hash for that switch. So if that is 1, then we're going to print that usage and just quit. So already, by the way the Windows works, you don't have to type the PL because of associations that the Windows does with the file name extension. But one measure of how useful this script is for me is that when I install it on Unix, I actually change the name to multi instead of multi.pl, and like the shebang line on the inside control. And that way it seems more like an operating system command. So if I use the -H, then it gives me that help message. And that will be ready to expand as we move on. So what do we have to do? First off, We have to pull that before pattern off of the command line. I'm a renegade Perl scripter. I don't use warnings and always scope my variables. You'll have to excuse me, that's just my style. We pull the after pattern off the command line. Now I've got to do something with it. So everything we can find in the current working directory that has that, that's what glob does. It's basically the ls inside of Perl. And so we get this array of files. I'm not going to spend a lot of time introducing Perl. I'm assuming you're familiar. But this @sigil means that this was an array of files, and the $sigil means it's a scalar. So there's a single before pattern, a single after pattern, an array of files. And now I'm going to loop through these things. And what do? For each one, we have to create the destination file. So that takes a copy of it, and then it's in one line. I never do 2 lines when I can do 1. I substitute the before pattern for the after pattern. Build up commands. Move the file to the target. Print. Command, put a new line on there. And for now, I'm not going to do anything yet. But when I'm ready, so that red with a hash is a comment, but when I'm ready, so I'm just testing right now. So then I will say multi-move. All right, so that printed out all the commands that it will do. And if I'm satisfied with that, then I can go back into the script and uncomment this and make it happen. But instead of just doing that, I'm going to add this extra test feature in here. Document it first. I have to make sure that this knows to look for a T-switch. And then what I'll do down here is use the T-switch. Okay. So now, they print those things in the screen. If I do a listing, the file names have not changed yet. But because I printed it, I'm satisfied. I check these. Sometimes what I do is I'll copy and paste and execute 1 or 2, make sure that it works properly before I release the Kraken on everything. But this is pretty easy. So I'm going to go ahead now and get rid of the test. And it actually does that. It's actually surprisingly slow, but now we're done. And if we take a listing, we have some much more manageable file names. Voila. By the way, I'm happy for this to be very interactive. Just go ahead and interrupt me if you have any questions. I guess you guys are unmuted. You've been well behaved so far, so we don't have to shut you down. So go ahead and interrupt if you have any feedback or questions.
Ruben, why are you using bangs instead of forward slashes on the regular expression?
Why am I using bangs instead of forward slashes on the regular expression? So he's talking about these bangs here. Mostly because it's quite common for me in a regular expression to actually need the forward slash character as one of the things I'm searching for or replacing. I've never needed to search or replace a bang, and Perl allows you to use whatever delimiters you want within reason, so I always choose bangs for substitutions. I don't always choose bangs for matches because if I was to do that, I would have to type the letter M, and I prefer to just use a slash, which is a shortcut for search for a regular expression. Just my habit. Okay, so let's move on to the next. Oops, where am I going? Going to PowerPoint. Presentation. Okay, so that's done. Next case. So we wrote this script, but it's pretty obvious to see that, well, it works for move, but whenever you're moving files, there's also the option maybe you want to copy them, right? You don't just change the name, but you want to leave a copy of it behind. So maybe we can make this a multi-move and copy switch. How could we do that? Well, one option is you could use these command line switches to enable a different behavior. So we can maybe put a -C switch that says copy it instead of move it. But if you think for a second about this, it's a pretty widespread paradigm to have a command and two arguments, an input argument and an output argument. It's not just copy, it's not just move, but it's lots and lots of things, which is what allows the explosion of usefulness that we're going to see. So instead of adding a switch, I'm going to change the way that the whole thing works by adding a new argument at the beginning of the argument list, which is the command you're going to use. So I'll take the move out of the name of the script, and I'll put it into an argument, and then I can put any command I want in there. So another thought is, one of the things that we did is we searched for all the files in the current directory that match the before pattern. Well, what's so special about the current directory? Well, if you want to work on things that are in some other remote directory. So what we're going to do is we're going to keep this default behavior that if we just give three arguments, command, before, and after, we'll search in the current directory for things that match the before pattern. But we will also add the ability to specify our own list of things to act on. And that list of things could be absolute or relative paths to files that live in other places. All right, so the job that we're going to do now, let me show you what this looks like. So this is debugging output from something that I wrote a long time ago. And each one of these, this is registering video frames to reference imagery. So for each one of these, there's a job that happens on different frames of video. And each one of these, every time it tackles one frame of video, it creates one directory's worth of debugging information. So there's these four images. So here's reference imagery. Here's where the video frame was before. Here's the reference imagery after we've found it, what the match is, and there's the video frame superimposed. Yay, it worked. That's nice. Next we go to test 1. Okay. It's pretty convenient in Windows to just use the arrow keys to cycle through all the images in the directory. But all of these images that I care about are in different directories. And I mostly only care about this one that shows if the video frame lines up. So what I want is for all of these images that have the 3 at the end to be in the same directory, so that I can just open one and then use arrow keys to quickly cycle through them, like a flip chart. So that's job number 1, to promote all of these files from the subdirectory level to the higher directory level, since they all do have unique file names because they have this number in here, which is the frame number from the video. So once they get into the same directory, and I think we can do that already. All right, so there's all the test directories. I forgot. I'm going to take this thing and change the name. So I'm saving it as multi. Change the self-documentation as well. And let's see if we can make this script do this. So there's my multi-script. What do I want to do? First of all, I always try first with a test. I want to copy, and I want to change a slash to an underscore. Oh, but I'm not ready to do this yet because I need to be able to specify the input list.
Did you just say that it's multi.md?
Yes, I did. Thank you. Good eye. All right. So we need to. This is the default behavior that happens if you don't provide any arguments. But if the user does provide a list of files to act on, then that's what we're going to want to do. So we'll only do this glob if the user hasn't given us any files to work with. So we pull those. Oops. The other change is that we change the argument list now. Okay, so first we pull the command off, then we get the 2 patterns, and if there's anything left, that's what we're going to act on. If there's not, we'll search for things that match the before pattern. So now we have to go through these files, generate the target files. We have to change this command. We're not always doing move anymore. So that's the command we're going to do. And we'll print it. And if we're not testing, then we'll do it. So now let's try it. Make sure that they're doing the one in this directory, not the one that I have in my path generally. So we need to, with testing, we want to change a slash into an underscore on all of the tests. So let's see what this does. Look at that. Lots of nice, juicy. Okay, it made a mistake. It's trying to use a command of slash. Why did it just...
Well, I don't think you put in the command in the command line.
Ah, good catch. All right, so I need to copy. That's what I was trying to do before. Okay, so these are the commands it's going to try to do. I'm going to copy from the test63 directory. It found this file that ends in 3.tif, and it substituted this slash for an underscore. So it doesn't know or care that there's stuff living in other directories. All it knows is it's got a string, found a slash, changed it to an underscore, and in effect, when we build a command out of that, it's going to copy the file from the subdirectory into the current directory with this name. All right, let's do that. Okay, next problem. TIFs are big, and I'd rather have them be JPEGs. So what do I need to do? I have ImageMagick, open source image manipulation command line suite installed, so I have a command called convert. You give it an image, another image, it'll figure out how to do the conversion. This one's pretty easy. I want to convert, so now I'm finally adding a new command. I can add any two argument commands. I want to convert TIFF to JPEG, and that's what it's going to do.
Put all those images copied up to the directory you wanted?
Yes, here I am in the directory. Let's take a look. So I've got all the subdirectories still, but now I have all of these files. Yes.
Do your little trick with the right arrow. I want to see them.
Okay, yeah, this is fun. So that's pretty cool. Now, this is actually working pretty fast, but if the stuff is bigger, then this could actually go slower than your finger because it takes time to load each image. That's another reason that you want JPEGs. So let's convert these. Oh, do we have questions online? Right, so while those are converting, how do I get? Thank you. Yes, it should be multi-Perl. Windows file extensions tip. Thank you. Torrent has agreements. I like agreements. All right, back to work. Okay, so those are all converted. I can get rid of the TIFFs, and now I've just got JPEGs. But here's another problem. If I list these things, you can see that they are out of order because, can I close that? Yes. Because the number of digits is not the same. You've got a lexicographical ordering. So I want to fix that. So what do I need to do that? I think I can do it already. All right, so what am I doing here? Let's test it first. I'm going to change test to test00 for all of the files which meet this pattern. These then become the arguments of the script. Start with test, and then question mark is one wildcard, and then underscore whatever. So that picks out just the single-digit ones and operates on them and converts them all to 3 digits. So that was the right thing that I want to do. These commands look right. I go ahead and do it. And I need to do the same thing for the 2-digit ones. Add an extra 0. Now when I do a long listing, I can see that everything has 3 digits, everything's in order, everything's wonderful. So, and they're all JPEGs. So I can whip through these and it's almost like watching a video. I don't know how you guys on AT&T see whether the pixels come across fast enough, but I hope you get the idea. I think that was our goal for this one. Did we do everything? Yes. And we're burning through time, so let's move along. Unless there's any questions, feedbacks? Okay. One of the really fun things that I like to do is to use diff as the command. You can plow through large numbers of files and find out what's different. And when you want to do this is when you have a large number of files with a small number of changes. So I ginned up an example where I took snapshots of code trees from something I've been working on recently over successive weeks. So we can find out what changed in these files. Some of the things that we want to, well, let's just do it first because you can already do it. So I made a copy in my new example directory. And example 2 here. I've got my script that I'm going to work on, and I've got all these directories. Each one has a timestamp of when I grabbed a snapshot. It's easy to do by setting a timestamp in a clear case view and copying everything out. So what if I do, what changed between, let's go from 12th of May. Now here I have to enter a lot of files. And I can do that on the command line. I find everything in that directory. It's going to create a huge list of files. I enclose that command in backticks, which means that the result of that command gets dumped into my command line. So now I've got all these files are going to be all these extra optional arguments to the Perl script that are going to be diffed, where we substitute 5.5 with 5.12. Let's just test to make sure that it's going to do the right thing. So those are all the commands that are going to come out, many pages of them because there's lots of files in there. But it's going to diff the 5.5 version against the 5.12 version for every one of those. And what happens when we do that? Well, a lot. There's a lot of changes. I was a busy guy. But then some of the things didn't change. Like you can see, if it just has a diff as a line with no output, then it didn't change. Okay, so first of all, so how can we make this better? First of all, you may want to suppress any output if there's no changes. Some kind of thing you want to do with this, because that's the way the diff itself operates. If we look close at the output that's scrolled all by there, we'll see that it gives these bizarre warning messages when we try to compare directories. Probably not so interested in diffing directories, so we can put in a switch in there that will force us to only do something when there's a file. We may want to forget about the diff commands themselves and just see what are the differences. And we may also want to go the other way, which is to suppress the differences and only list which files had some differences. Or even we'll get to that. So let's start making some changes. What was the first thing? Be silent if there's no commands. Okay, so if you're doing a grep and you want to find out, if you do grep for a pattern on a bunch of files, you get all the lines in the files that have that pattern. But if you just want to know which files have that pattern, there's a switch called -L for list. I'm going to do the same thing here. I'm going to do a -L switch. So we've got to add the switch here. And only list the commands that gave us some standard out. So down here, I'm still going to build a command, but I'm not just going to run. I'm not going to print the command unless it yields out this. I'm going to have two modes here. So L mode, list mode, and regular mode. So if we're in list mode, then what we need to do is not print and then run. We need to run first. Now in Perl, we run the command in backticks, and what happens is it goes, sends that to the operating system, gathers up all the standard outs, and gives it to me in my scalar variable that I called standard out there. And I'll print that command if standard out happens to have a non-empty value. So if we got some standard out. So whenever there's a diff that returns no standard out because there are no differences, then I will not print the command that yielded that. I think that should work. Let's give that a try. Same command as before, but now with an L switch. All right, so you can see that it's, well, it's unfortunate because it's, anybody identify the problem here?
New line.
New line. Thank you. I want to, let's just put the command with new line in there. That way it'll always be there for us. And if we're going to put it in there, we got to take it out of there. Let's try it again. That's better. So here's a listing of the commands that produces some output. I think it's done. Yes. Not so many compared to all that. That's useful. All right, so now what are the differences? The other way around.
Just don't quiet.
That's going to totally break it. Okay, so
You've contributed.
now what we do is, all right, this command is, we don't need quotes anymore. Now this script is broken unless we make those align. It's my particular OCD hell. Okay, so now let's try the same thing with a Q. I go through a lot of stuff. Still printing the diff commands. Why is it doing that? I always forget to do that. Didn't actually parse that Q off the command line.
I was going to say something, but I wanted you to learn your lesson.
And I wanted you all to read your lesson, which is why I did that on purpose and didn't tell you. Okay. Still print it out. Let's do the ignore directories thing first so we can get that out of the way. This is pretty easy. So we go through this list of things that we've been told to work on. If option F for file is on and it's a directory, this is a file testing operator, then we should just next. So that's like continue in C++, go to the next operation in the loop. Still doing it. Oh, not D, it's F. Yes. Okay, so appears to be working. No directory warnings, no diff commands printed. Great. It was, I think, so we did all of this, but this last thing. So now, let me return to the listing mode. This is nice to see the list of diff commands that created output. You know what changed. But what are you going to do with it? Well, if you want to act on these files, you can, I don't know, paste these file names, or you can try to paste these. They're not aligned. And we all know no alignment is bad. So we can make options instead. I'll just do one of them. Not probably the best description, but here, instead of printing out the whole command, I'll just print out that file name. See if that works. Made a mistake. Okay, so now when I do this, I have a specific list of the files that changed. Now there's the directory too. I forgot to put the F switch. But now I can take this specifically, paste it, and do something with it, or I could even enclose this in backticks. Actually, I don't know if that is going to work, but I could enclose that list of files and give that to another command to operate on somehow. So and you can do the same thing for, you can make a B switch for the before files. You can come up with different ways to do it. So are we all good with diff? Ready to move on? Next, use case. Regression and unit testing. This is, I think, the core of the whole thing. I would love it if every tester at BAE used everybody that tests command line utilities used multi to just create giant repositories of input files, benchmark files, and run the inputs to get outputs, compare the inputs with the outputs. And I'm not sure we even need to change, oh yeah, okay. If we're testing commands that are of the form command, input, output, we don't need to change anything. We can do all of this. I hope you can get the idea how. But sometimes commands deal with their inputs and outputs in different ways. So sometimes, like by default, if you write a C program and you compile it, you have to, if you want to put it in a name other than a.out, you have to use a -o switch. Very common for things that use -o. So you need to be able to build commands of the form command -o output file, input file. A lot of times also, file prints its output to standard out. And we need to use a redirection, a greater than, to dump it into another file. So we need to be able to build commands of those forms. And you could conceive of files that have other switches that they use to specify their output files. So we can build in a capability for generic switches. Now, so here's, I made this fake Perl development task. So WC is word count, very useful Unix command. I use it a lot, but it's not a native capability on Windows. So your supervisor says we're installing this on Windows and we need for them to have something like a word count for these couple special little cases. We want it to be able to operate like word count normally if we don't give any switches. If we give a -O switch, we want it to put the output in a file rather than stand it out. And if we use a capital W switch, we want it to write it into a file, and we only want the word count, not line and bytes. So there's my task. I have do this in the next directory. Mostly kind of created this script. I'm not going to do that one on the fly. So let's go about this task. I've got all these input files. So here's a log file. It's got a whole bunch of crazy text in it. BE text has begins and ends in it. That was a sample text from Ryan Blackshear that had a bug. We used it for debugging. This is just lots of different files. Dates, floats, 1,000 floats, ints and words. The entire Project Gutenberg text of War and Peace. Got a lot of files that we're going to work on here. So first of all, we need to capture what's the benchmark performance of word count that we need to match. So what I'm going to do, well, I need to run. All right, so that goes to stand it out. I need to put it into a file, and I don't want to do that for every single one. That's what we wrote multi for. All right, so we need the redirection capability. Time for a new switch. Documentation could be better. Don't forget to actually implement it. Not completely. All right, so where do we do this? We do this when we build together the command. So if we're in redirection mode, then we build the command a different way. Looks good. Put the T on there. So those are the commands it would do. If we're satisfied that that's what we want it to do, and we'll go ahead and do it. All right, so now we have a set of benchmark files that we need to match. So now let's see if our script works. This is going to be a problem because this is running not only on our inputs, but also it's running on the benchmarks that we already have. We don't want to do that. So how about instead move all of the files from text to in.text. Now we have all of these things that we can fix. All right. If we take a look, we've got all input text and benchmark word count tests. Multi-word count, oops. Test the redirection. We want to convert in text to out not going to line up. It's going to bug me. Only on the input files. That's the right set of commands. Go ahead and do it. All right, so now we've got ins and outs and the word counts, and now we've got to find out, are they the same, the outs and the benchmarks? Are we done with our task? Looks like we did a really bad job. So oh, whoops, okay. We have to recreate our benchmarks. I remember hearing about a calculus teacher that in college, he had 2 different sections, 8 o'clock and 10 o'clock, and gave the same lecture every single day. And he consistently found that the 8 o'clock students performed better. And what he eventually figured out was that he made all his mistakes in the 8 o'clock lecture, and at 10 o'clock gave a polished lecture with no mistakes. And so those students were ill prepared to tackle the mistakes that they did when they tried to do it themselves. So I hope that this process is more useful for you. So let's try this.
Both by design.
Yes. It's by intention of this, the way that I structured this.
That's right.
Still everything differs. Why?
Doesn't it make it possible to go faster?
If I can write a Perl script to deliver this for me. Okay, well, the results are actually different. Let's find a... Okay, so if we look at int 10, that's the input. Word count says yes, that's what it comes down to, this 20 and 30. There's 10 lines, 10 extra bytes, and that was the error that I intentionally put into here. We just add one more byte. Kind of run out of time, so oops, that was the wrong thing to do. We need to recreate our outputs. Oh, and then when I diff, oh, I think it's better. We might not actually come to completion on getting a clean diff on this. All right, smaller list of problems. What's the difference now? Something, oh, I know what this one is. So here we have a different number of words. And the reason is because it's a question of splitting on one white space or any number of white space. So in here, when I split my line into words, I change that, I believe, let me get closer. So I rerun. Yeah, so before it was splitting on one space, so when there were multiple spaces, the list of words was getting these empty words in the middle that were getting counted. Now when we split on multiple spaces, that doesn't happen. So we re-verify, same differences. I'm just going to cut this example off at this point. I think you get the idea that I've created an environment where I can very quickly test changes across a large set of inputs. So it's good for getting it right in the first place. Then you have these benchmarks, which are the should-be performance, and you get a bug, you got to fix something. You say, okay, I'm going to create one more input-output benchmark that creates the behavior I should be seeing. Do my verification, I see the failure, and then I work on testing it, and I keep verifying until I fix it. Not only do I fix the one, but I'm testing the whole suite. And so the unit testing and the regression is a good safeguard. We all know about that kind of stuff. So we're not going to go and put those extra switches in because we're running out of time. We're going to go to the last example. Sometimes you've got file names that have spaces and punctuation. Very useful to be able to deal with that kind of thing. So let's now if we go and we take a look at what's in here, we've got all these file names, which are, I can't even tell where the long listing ends and the file name begins. I think it's right here. It's got parentheses, it's got punctuation, it's got spaces. This is the kind of thing that you always get when you rip a CD, right? So these are all lossless FLAC files, and I'd rather have MP3 so that I can play it on an actual device. So I have Lane installed. To test. Okay, it looks like the right commands. We've got lane, and I've got my input file, my output file, but if I actually test one of these, if I actually was able to use the mouse to select ones that I could test it, then we would see that it would fail because it's got like 40,000 arguments because of all those spaces. So we need to fix our script. Now, one way to go about it is to put a switch in there that says protect everything, make sure it's escaped. Maybe it's a -E switch, maybe it's a -Q for quote, but we already have Q for quiet. But I think the better thing to do is just to make it work out of the box. So let's just see if we can do that. If my file has any non-word characters, let's I think it's okay if we just use quotes. I don't think we need to use backslashes to fix every character, but we could if we need to. Just test it. I'll make it look pretty. So now, do the same command. Why did it not? It should have been defined after here.
You need a G after that test?
Do I need a J?
A G for global? Or you're doing the search for the string?
Well, it only needs to find one to trigger the behavior that I want, I think.
Gosh.
Let's yes, absolutely. Stick around at 2:30. I'll be presenting this again. It'll be a lot shorter. Oh, I Anybody see the error? So, no. Okay, how many people have faith that I can fix this given enough time? And get the point.
We got 5 minutes, right?
Yes, but I do have a couple slides that I just want to push through and then end on time. Plus we got administrative to get through, and somebody's going to win a book. Did everybody put their names in? Anybody that didn't sign in needs to sign in. Anybody that didn't enter their name into the jar there? Oh, okay, so she's going to draw a number and somebody's going to win a book. There's more that can be done with this script. I've had this script going for 5 years at least, and every few months it seems that I come up with another use case. Oh, I should be able to do that. And then I put that in, and so it's grown a lot of different capabilities. -G was just mentioned, is very useful. So if you need to substitute the before and after more than once in your command, you can cause that to happen. -1. Sometimes you have commands that you say the command, you give it the input arguments, and it figures out what to do. It doesn't need an output, but maybe there's a side effect. Maybe it figures out the output name on its own. So I put a -1 switch so that I could operate a whole bunch of one-argument commands without requiring second arguments. I even put a -0 in there to just run a whole bunch of commands. So if I got this list of commands, I just want to run them all, then that's what that will do. I'm sure more things will come along as I happen to think of them. If you guys happen to think of any that would be useful, I'd love to hear about it. You can tell me now or tell me later. And this was titled the most useful Perl script ever made, but I have some other scripts that are also in contention because they are useful and they are extremely short. So because you're dividing by the number of lines, that gives it a head start. So I've got a whole bunch of scripts that I use in piping chains when I pass standard out, standard in into a bunch of commands. So there's one called sub.pl, and this is basically the script in a nutshell, these 3 lines. It's also, I've got a before and after pattern, and what do? I go through all of the lines that come in through standard input, and I substitute before and after, and then I print it. I added a -G switch if I need to substitute more than once, but it's very useful because I'm all the time getting these huge log files and piping them through all these filters to grep out just the lines that I want. Sometimes the lines are really long and I want to reduce them, or I need to change file names or paths or all kinds of useful stuff like that. So that's kind of a general one, but I have specific ones like space to CSV. So I've got a big old log file with a whole bunch of numbers in it that are separated by white space. I pipe that through space to CSV. Maybe I pipe it through a sub first to get rid of some crud at the beginning of the line. Pipe it through space to CSV, and I've got terms of space and the commas. Dump that into a .csv file, double click, Excel, boom, I'm analyzing. Space to tab, same kind of thing, all different directions. Times and plus. What if I've got a file that's somewhere in it, it's got some numbers which are in radians. And I want to see what they are in degrees because that helps my brain to think about it. Well then, I just pipe that whole file through times and then actually implemented a switch for specifically radians, degrees, radians. But if I knew the number, it was about 57, you could do that. And every time it finds a number, multiplies it and prints it that way. You can do the same thing with plus. You can use negative numbers for minus. Every. What if you've got this log file that has output for same output line 5 times every time something interesting happens, which is what GXP does. Every time you move the cursor, put an image to ground like 18 times. And so if you put a debugging statement inside of image to ground, you get it repeated over and over and over. So every.pl, you give a numerical argument, and then it prints, so you say every 2, and the input that comes in, it prints every other line. Every 3, it prints every 3rd line. There's also offset switches, so you can say every 3rd line, but skip the 1st one, so that you go at different places in the mod3 list. Sub in place is a slightly different script. I'm all the time getting these support files that have bad paths in them. And I know GXP can repair those automatically, but that involves clicking with a mouse. I prefer to use the 114 mouse. So if I want a file that has these kinds of things in it to look like this, I can do that with a command that says sub in place, dot dot because I don't want to worry about backslashes. And this is a regular expression here, GLVD dot star all the way up to image. Replace that with V colon beta image and all of my star dot subs, and that changes all of these lines to look like that. Very useful. And final one, everybody knows how to use diff, and that compares lines against lines, and it's useful if a whole bunch of lines got inserted. You can find that. But sometimes you have files that have numbers in them that are really the same, and you want to find out if they're numerically different. So if you have a file that maybe one file says 0, another file in the same place says 0.000000 e plus 000. Well, diff is going to say that's a difference, but I want a script that's going to tell me that's not a difference, and also be able to do with tolerance. So as long as your two files are the same shape, which means line for line they correspond, and in those lines word for word they correspond, it'll compare every word it finds, space-separated group of characters, and if it's a number, it'll compare it numerically and tell you if there's a difference, and you can put a tolerance. So that's useful as well. So you can set it to 0 if you want to know if there's any difference at all. You can set it to a small tolerance if you expect a little bit of difference. And that's all I have. If you want any of the example stuff in here or the scripts in progress, you can go to this path with the BB on the end for brown bag. If you take the BB off, then that's my working real-time Perl script directory. You can find those other scripts in there. Go ahead and copy them out. Don't mess with my stuff, but help yourself to a copy. And thank you for coming today. It's time for drawing.
Okay.
2 votes today.
2 winners.
Got some pretty cool looking books in there too.
All right. Kylie, come take a vote.
I'm going to lay them off.
Number 4, Ryan Hoffer.
All right.
Get here early today. 3 and 4 were the winners.
You said Ryan, and I first thought Toma. I was like, that sucker didn't come to the room. He could have got a book.
Win in place and no show today.
Ruben, I thought identifying that you could take that command and pass it like a binary operator and pass it as a command to a script instead of writing like multi-move. I think that's huge. And that's like a concept that can be applied to like programming in general. You know, I mean, like in C++, they have a lot of like the binary operator has its own little special place, and they have functions that are especially made to take binary operations by argument. It's like the concept of taking a function.
Right. Like passing a function as an argument or executing a function inside.
Right.
Yeah, it's a lot easier at the operating system level because really you're just playing with strings.
Right. So that means you said you can use your multi-scripted unit test other Perl scripts and things. They don't have to be Perl scripts. They can be all kinds of things that you would write to generate output. You know.
Anything that you can make happen from the command line.
Right. I think unary operators are other things that are common. What you add is just a -1 and -0 switch. I thought was cool, but that would be super useful. You know, I think that concept is like has big implications.
Hey, it's powerful. Thanks.
Were the slides available?
These slides are in this BB directory as well, so you can pull them from there. I don't know if INS is going to post them as well.
They'll post them on the wiki and send all things out there to the class, but it won't happen immediately. You better go grab them out of here. The needs aren't here.
Right. And that directory has all those example folders with the test data.
Okay. Yeah, very well done. Very good.
You put your scripts in there in the GXT box?
Diff-pred is in the VODs.
That's frequently.
There was an early version of Multi that was checked in the interface for CDC, and it was in the bridge that got delivered as an early for the product. When at that early point,